In another video, we have talked about this modem, U10C105, mainly talk about the NAND flash here. There is a second flash, which is SPI, 4 meg SPI flash here. In this video, I'm going to solve two questions. One is how can I find the layout of the flash, which can be used to create the proper XML. Second is whether the 3.3 volt from the U10C is safe to use on the flash here or not. Let's first take a look about the way to find out the layout. And I'm going to use the USB TTL hook up to the serial port here to log the boot up and find the information that will tell me the layout of this SPI flash. So in order to do this, I'm going to plug in the serial port and power on the unit. The tool I'm using here is called PuTTY, and it will load the serial port here, and the baud rate is 115200. So open it here. Then I'm going to power on the modem. It will start print out informations. So let's wait it stabilize. By the way, other people might find more information from this log. My purpose is to find the layout of the flash from this log. Okay, I'm going to power off here so it will not scroll anymore. So now I can go up. So at the beginning here, it have some errors here. My main purpose is find this information. You can see the boot log shows we have the NAND flash. We also have the SPI flash. This is something I need to look at. And here is the XML file I created based on the information from here. You can see there is a block of data called BOLT, and I created a block of segment called BOLT, and the address is 01300, and the same as here, 01300. Okay, so the second was MAC address, MAC-ADR. So MAC-ADR, and the starting address is here. Now this is the size. In the definition of here, it's the start address and ending address. So if you minus 1400 with the 1300, and you will get 10000 here. Okay, so next block will be NVRAM, and then NVRAM 1 and dev here. So it is always 1-to-1 match. So SPI flash is quite easy if you have this information. Now I have also created a NAND definition based on information here. And you see there's a kernel 0, we have kernel 0, kernel 1, CM0, CM1, and RG0, RG1. However, you will see the address is slightly off. You see here, instead of 62000, I'm talking about 65100, because the definition here is the pure program, or pure, without the ECC, but we know the NAND flash had the ECC or the OOB, out of band data, and this definition is including the outbound data. So let's say 2 kilobyte of sectors on the NAND flash has another 64 byte of OOB data, and that's being included here. So 800 will be the sector size, but 840 is the sector size on the NAND. And So we can see here, based on the serial port log, we can define the flash properly. Now let's talk about how I find out if it's safe to use 3.3 volt from U10C. And the way to do this is I'm going to apply the 3.3 volt with this device and see the amperage this chip uses. If the amperage of this chip use is less than 400 or 500 milliamps, then we know it's safe to use the U10C power. So the way to do this is I make it a pure clip here and remove all these connection to the U10C and only apply the volt power supply, which will have one ground and one power here. Then make the connection. Okay, I have made the connection. Now I'm powering on. I see 3.3 volt and only draws 170 milliamps. So that way we know we can either use the external power supply as we do now, or we can directly use the power from the U10C, because this can draw at least 400 and 500 milliamps. So it's very safe to use the power from here. Here I have made the connection from U10C to the this connecting board, and you can see I have used the 3.3 volt from the U10C, and I know it's safe. Okay, now I can plug in the USB to the hub here and connect the chip. Here I can read and you can see the data match the layout we found. Here is the data we found, and you can see a lot of segments, the data matches. So if we want to play with these individual sectors, you can erase here or do data extraction from here.